when it comes to precisely measuring the thickness of small, thin or intricate components, such as machined parts or small diameter pipes. How do you quickly and non-destructively measure the thickness of the material when you don't have access to both sides? Typically, you would use an ultrasonic precision thickness gauge. When you need to measure thin materials with pinpoint accuracy, the DakotaNDT PCX8-DL precision thickness gauge are designed to measure on virtually any uncoated thin material. The DakotaNDT PCX has an easy to use menu system with multiple languages, meaning they can be used straight out of the box with little or no training required, while still delivering highly accurate material thickness measurements. Taking a reading on very thin substrates when accuracy is critical couldn't be easier. Using a very small amount of ultrasonic couplant, press the transducer flat against the surface. When the transducer is placed on the material, the reading stability indicator will show how strong the ultrasonic signal is. A red or orange bar means that you need to adjust how you're holding the transducer. But if the bar is full, this means you are going to receive accurate and reliable measurements. The DakotaNDT PCX range uses single element delay line transducers to promote accurate material thickness measurements to 1/100th of a millimeter or 1/1000th of an inch of thin, uncoated materials such as steel, titanium, and plastic from as little as 0.15 millimeters thick. So, how does it work? Single element transducers consist of a piezoelectric crystal which emits an ultrasonic pulse when triggered by a voltage. This energy pulse travels from the transducer and into the material, aided by ultrasonic couplant. It then hits the back wall of the material and echoes back towards the crystal, where it is then detected. The gauge then uses the speed of the pulse and the time taken between the pulse being emitted and the echo being detected to calculate the thickness of the material. However, measuring thin materials means that the ultrasonic signal will return to the transducer incredibly quickly, meaning there's not always enough time between the pulse leaving the element and the echo returning. This is why, when using a DakotaNDT PCX, single element transducers use a delay line to both increase the amount of time between the pulse being sent and the echo being received, and also make sure that the material being measured is outside of the transducer's near field zone, which ensures more accurate results. The material you are measuring will affect the material of the delay line you should use. For example, acrylic delay lines are suitable for measuring on steel, aluminium, and titanium, while thin plastics and other similar materials should be measured using a graphite delay line, with the gauge set to plastic mode. You simply input the length and material of the delay line before starting, and the gauge will subtract it from future measurements, leaving just the thickness of the material. Whenever you change delay lines, you should ensure there is a small amount of ultrasonic couplant between the delay line and the transducer, making sure there is no air between them. And always remember to change the delay line setting within the gauge. When measuring on materials that deflect or absorb the ultrasonic signal, the DakotaNDT PCX gauges only allow you to save a measurement if the signal strength indicator is in the green, avoiding false or incorrect readings. The DakotaNDT PCX thickness gauges are designed to work with DakotaNDT's range of intelligent transducers, which all have automatic probe recognition. As soon as the transducer is connected to a gauge, it immediately detects what type of transducer you're working with. All you need to do is set the appropriate length and material of the delay line and input the frequency and diameter of the transducer. The DakotaNDT PCX range has user-selectable measurement rates up to 16 readings per second, otherwise known as 16 Hz, making them ideal for scrubbing across a surface and recording multiple measurements. The DakotaNDT PCX8-DL has scan mode for checking large surface areas. Simply scrub the transducer over the test area, and the gauge will display the average, lowest, and highest thicknesses across the scanned area. In addition to displaying the material thickness, the DakotaNDT PCX8-DL has a choice of displays, which includes user-selectable statistics, thickness bar graphs, and run charts. The DakotaNDT PCX8-DL is also equipped with time-based thickness B-scan mode, which shows any changes in the material thickness visually as you move the transducer across the surface, making it ideal for quickly identifying large changes in depth within the material. Alternatively, Differential mode displays the last reading and how much it differs from the user-definable nominal value, also known as the target thickness, indicating where the material is thinner or thicker than expected. With limit memories, the DakotaNDT PCX8-DL allows you to set high and low limits, as well as previously mentioned nominal target thickness. Once defined, whenever a reading exceeds these limits, the gauge gives you an audio-visual warning, clearly highlighting any problem areas. The PCX8-DL has a range of calibration options, with simple, on-screen instructions that guide you through each method step by step. To find out more about all calibration methods, make sure you watch our Ultrasonic NDT calibration videos. Storing up to 100,000 readings in up to 1,000 sequential or grid data logs, along with statistics, limits, and calibration information, the DakotaNDT PCX8-DL can transfer all of this via USB or Bluetooth to DackMaster, our free application for PC, or into a number of common formats. For more information on DakotaNDT's full range of NDT inspection gauges, simply visit DakotaNDT.com or click on one of the links on screen. And please don't forget to subscribe to the Dakota NDT channel to be notified of any new videos.